Well, in a couple of days' time, it's the Chinese New Year, and we thought we could mark the Chinese New Year by looking at a bit of the chemistry of tea. So before we start, have to make some tea. We'll just go along the corridor to the staff room.
Don't drop them.
Yeah. So we're going to make some green tea and some ordinary tea as well, so we can compare them. I don't really like black tea very much, but I'm very fond of green tea. And they're the same plant, but they're just processed differently. And we put some in my teacup as well.
That's just for personal use, is it?
Yeah, that's for just keeping me going. Chemists never trust drinking out of beakers. So we'll give each of them a stir and then go back to my office. It's the green tea. It's the ordinary tea. I want to try and show you what happens when you put lemon in tea. So if I cut the lemon in half, and you know lemon juice is very acid. So let's see what happens. I will move the two together, so all being well, we can compare them. So, are you ready?
I am.
We'll try squeezing in some lemon juice. So, apart from the pip going in, can you see that as we have added the lemon juice, it's gone a really much lighter colour. And the reason for this is that tea contains molecules or chemicals that behave like so-called indicators. They change colour when you put acids in. And what happens is that the acid from the lemon juice adds a proton to the molecule of the indicator in here, the one that changes colour. And just by adding this proton, it causes the bonds in the molecule to switch round, and so they absorb light in quite a different way. Now, tea doesn't give you a terribly dramatic colour change compared to some of the indicators that, like litmus, that people have used in the lab, which can go from pink to blue, but it doesn't do badly. There's quite a lot of argument whether chemically it makes any difference if you put the milk into the cup before the tea, or you fill up the cup with tea and then add the milk afterwards. And there's some people who get really passionate. They will only drink tea with the milk before or the milk afterwards, and they swear that there are big differences.
Do you have a position on this?
I don't have any position at all. I don't like milk in tea, so I don't enter into that debate at all. The different sorts of teas that you buy are basically the same plant, but they differ from the different components that there are in the tea. When you put tea in water, the hot water, extracts a huge number of different chemicals from the tea. These are not pesticides and things that have been added, but they're actual chemicals that are created by the plant when they grow. And depending where the plant grows, whether it has been a sunny summer, whether it's been a wet summer, so that the different amounts of the chemicals changes. So one of my colleagues who works here used to work for a company that sold tea, and they wanted to analyse it to find out how the different sorts of tea varied. So they used a machine like the one behind me, which is called a nuclear magnetic resonance spectrometer, NMR spectrometer, which measures the different sorts of hydrogen atoms in a particular molecule. Now, the problem with tea is that it's quite easy to get a sample of tea and put it in a tube like this. But this then goes inside that machine. You can see a whole series of them waiting to go in there. Those are not tea, but they're chemicals from the department. But what you end up with is a really complicated picture of all the thousands of different components of tea. And here I've got a real spectrum of green tea. And you can see it looks a complete mess. Lots and lots and lots of components along here. But the important thing is, and what they were trying to do in their analysis, was to see how the different sorts of teas varied and see if they could see a real difference between something that tasted nice and something that wasn't quite as good. And although you can't necessarily identify the individual compounds, you can say that some say here are due to different sorts of sugars, and these are due to more complicated molecules, the so-called polyphenols. But even a chemist like me doesn't really know what all these compounds are, though you can get an idea how one differs compared to another. Part of the reason why people like the dark tea rather than green tea is the dark tea has a lot more caffeine in it than the green tea. The processing of the tea concentrates the caffeine, and probably the fermentation actually generates more of it. Now, the caffeine doesn't have very much effect on the taste of the tea or of coffee, and so some people find that if they drink too much coffee or tea late at night, they can't go to sleep. And so nowadays it's quite fashionable to have decaffeinated tea or coffee. The problem is that the traditional way of removing caffeine from coffee or tea is using dry cleaning fluid. Dry cleaning fluid is a compound of carbon, chlorine and hydrogen, which sometimes can leave quite unpleasant residues in the coffee beans or the tea leaves. And so nowadays the preferred method for removing caffeine from tea and coffee is by using highly compressed carbon dioxide, so-called supercritical carbon dioxide, which can dissolve out the caffeine without dissolving very much else from the material. And CO2 is completely harmless in terms of health. People drink water with CO2 in it every day. And so it doesn't leave any residues at all. And the process is rather better with coffee, because with coffee it just removes the caffeine. With tea it does remove some of the flavour components, and they have to be put back in again afterwards. And the caffeine that you extract can be sold on to people who make caffeinated drinks, the ones that give you energy and keep you awake. And so this is a good process, because you put carbon dioxide over your tea or coffee and make a more valuable decaffeinated product, and you have some caffeine to sell to somebody else.
Stop.
Yep.
看，诺丁汉大学化学系元素周期表视频小组恭祝您牛年大吉，万事如意。
Good.
Oh, God, this really.